Good morning and happy band shirt Tuesday. I'm wearing Bon Iver today. We're back to the basics, one of my favorite bands. And you have joined me on the O-Scope Wizard Show. I'm Gabe, the O-Scope Wizard. I really appreciate you joining. Before the show, if you got here early, you might have seen a super ridiculous monster truck. And that's because yesterday I made a bad decision and bought a giant, huge F-250 monster truck, basically, all in an effort to pull a camper. We have this dream as a family of going on some camping adventures. We have a camper, but did not have a truck to pull it. So yesterday we bought a truck to pull it, and we vastly overcompensated and have a giant truck to pull it. But that's not what the show's about. The show is actually about not bad decisions on truck buying. It is actually about making a Raspberry Pi IRL subtitle machine. So I'm going to start the timer so we stick to our time. Time has started. I've got something to drink. It's Tuesday. It's a little rainy outside, which is kind of a bummer. But I'm not going to let that hold me down. Chat says giant truck for the win. It is a giant truck. It is funny because my little sister, when she was younger, she really wanted a giant truck. And this truck is gigantic. It is a diesel. It has ridiculously huge tires that I hope to trade for less ridiculous tires one day soon. All that said, it will pull a camper like it's not even back there. I think it will pull a house. Before I get too far in, Junior O-Scope Wizard, last time, one of them, Junior O-Scope Wizard, was on the show. She drew us a picture, and she wanted me to feature it prominently because it didn't really get a good shot in the last video. So this is it. This is the O-Scope Wizard as rendered by one of the Junior O-Scope Wizards. Oh, sorry. This is an oscilloscope as rendered by one of the Junior O-Scope Wizards. I was pretty impressed. And underneath, we have a Raspberry Pi hooked to a whole bunch of LEDs. So this is a Raspberry Pi 4 with a microphone cap on the top. We had a lot of trouble with the cap on the last episode because we could not get sound to go into our Raspberry Pi, which is I would say a critical part of a subtitle necklace. In order to make a subtitle, you have to start with sound. And we were really struggling with the sound part. I also have the power monitor. So today while we're doing the show, I'm going to hit the button up here and it tracks the milliamp hours that we're using. And I am curious over the course of this episode, how many milliamp hours were used, because that will tell us how long this tiny little battery will last. I have the LEDs working. So here are the LEDs right here. This is a whole bunch of LEDs, 2 strips of them, in fact. Here is the Raspberry Pi. It is wired up through the GPIO. I'm using the NeoPixels, which we've gone over in previous episodes. If you haven't seen it, just, I think hit the back button. But we have it wired up through the GPIO. Right here, we have the microphone cap, and here are the 2 little tiny microphones on the Pi hat. And we couldn't get this to work last time. So I'm curious to see if A, we can get that part to work, and B, if we can continue to have our NeoPixels work. I am going to drag this webcam view over a little bit. And I also want to capture my monitor. Let's drag this over a little bit so we can keep an eye on it. And then, let's see, I have some instructions for how to make this work. We are using SVAR, which is the Simple Voice Activated Recorder. A Linux distribution. It does work. It can work anyway, but I want to see if I type this in, if it will detect our sound. So one of the things it does is the signal meter. So if I type SVAR-M, hopefully it will use the default device and show us signals going into the Raspberry Pi. So let's try SVAR-M. This should give us a signal meter. If sound goes in, the signal meter will go up and down. Does sound go in? No, because it can't find the hardware parameter. So it's still struggling to find the sound card, which is fine, because I think I made the sound card the default. So that is card 1, 0. So it is the first card. Whew. And then let's try M. So I'm telling SVAR, or the sound recorder, to use the first hardware sound card that it detects and try to use that for the recording. All right. Oh, look, it is working. It's working. Why didn't it work last time? Why didn't it work last time? Well. Let's see why it didn't work last time. It did not work last time because if I do this right, is it this? Also, is it mixer? Okay. The simple voice activated recorder uses ALSA, ALSA, which is a, let's see, ALSA versus Pulse Audio. ALSA is a kernel level sound mixer for Linux. It is how Linux talks to the different sound cards that are plugged into your computer. Pulse Audio is a software mixer that sits on top of ALSA so that you can have all kinds of different things plugged into your computer. And Pulse Audio is like, all right, you got these 3 sound cards. I will handle the interface between your operating system and ALSA, and then ALSA will handle your interface between your hardware and the kernel. What I did not realize is at some point I installed Pulse Audio. Not on purpose, but Pulse Audio's default card was the HDMI card. And so when I tried to record, I didn't have anything plugged into the HDMI port, so it didn't detect it. If I go in here, you can see that I have headphones that are just built into the Raspberry Pi itself. That's not going to be a great recording device. Headphones are an output. But then I also have this Seed 2-mic voice card, which is what I wanted to use, and I was struggling with making that happen. So what I did was I made this card right here, the default card in Pulse Audio. Small thing, but without it, Pulse Audio could not detect my recording. And so SVAR, the simple voice activated recorder, I thought was using ALSA, ALSA, but it is actually using Pulse Audio. I mean, a lot of stuff was happening. It was kind of over my head, I will admit. Let's go to the website, in fact, for SVAR really quickly. If I go right here, copy, it'll probably bomb out because I'm not using a get, but it'll get us close. Okay, so when you install it, apparently, let's see, it says somewhere for installing it, it uses ALSA for other systems port audio, and it can also, well, it says it's using ALSA. So I thought when I set my card to ALSA, it would use it, but ALSA is using Pulse Audio as the layer. There's a bunch of different layers, and I didn't understand. With a little bit of reading, though, I was able to get my simple voice-activated recorder working, which is a thumbs up. A thumbs up. This was tough to do, but we have it. So now let's make a recording and then see if we can just decode that recording into text and then send that text to our LED. So we'll pause this. We need to actually make a recording. So I have set up a couple of directories. I've set up the speech directory, which I have a bunch of stuff in here. I probably should RM everything. Okay, so I deleted all the stuff that I was working on over the weekend, but I have a speech directory that's going to hold our sound files. And then I have a text directory that is going to hold our subtitle files. So let's delete all that. So everything is deleted out of both directories. We are starting fresh. Let's make a sound file into our speech directory and see if we can hear ourselves talking. We're baby steps now. We're like real slow. We've done this before, but not with everything plugged in at once and not using the simple voice activated recorder. The reason I'm using this simple voice activated recorder is because they've already done all the hard work for me. Like recording files and then stopping when it detects silence. I am going to copy this command. This tells the simple voice activated recorder to use the first default sound card, which is our microphone. And it tells it, what is L? We'll have to look at L. The rate is 1600 hertz, so that's the rate that it's recording at. F, we'll have to look at that for a second. You know what? Before I get crazy, let's see. I had done this before, and in my mind, I knew what was happening. Let's see. F is the fade out lag. Okay, so that is how much fade out it will have at the end of a clip. I think that is to be determined. S is when to split the file time. So that is when it sets a split. So I think when it detects 3 seconds of silence, it will stop recording, close the file, and then it will make a new file. So every time it hears a sound, it starts recording. And then when it hears 3 seconds of silence, I think it stops the recording. L is the signal level. So we were doing the meter before and it was going up to 100 and then it would go down to 0. So I set the signal level at 60. So hopefully when it actually hears me talking, it will record. So I am going to copy in my command. So level of 60, rate 1600, fade out 1000 milliseconds, split after 3 seconds. Real quick tip, pro tip here. If you're going to use time, maybe keep all the units the same in your program. Switching between milliseconds and seconds is just begging for somebody to misuse your program. But that's neither here nor there. And we are saving it to the speech directory here with the file name of rec-day, hour, minute, and second. So this should give us new file names as we record, and let's do a couple of tests and see if we can get 2 or 3. And the downside of this is I think my Raspberry Pi is going to crash in a second, but we'll see. We are testing our simple voice activated recorder. Is it working? Hopefully we have 3 files. Oh! Well, if you can't see, my lights are flashing. My Raspberry Pi has crashed. I need to turn it off and turn it on again. We lost our milliamp hour reading, unfortunately. I haven't figured out how to eloquently shut that down. I think in the real operation, what I would do is have the voice activated recorder run in the background. I did. Chat says I made a strobe light. That was an accidental strobe light. So I would need to run that voice activated recorder. I don't want a strobe light. We're not trying to make a strobe light. If only, look, now I'm disconnected. It's like you disconnected. You lost it. Let's see if we can find it. And we're connected again. If I open back up my file here, I think I even had a FTP. Let's see. Let's see if the FTP, let me make this nice and big. I think we are connected back to my FTP. So FTP will let us see what files were made. It looks like it actually made, instead of 3 files, it made 1 file. Not exactly what I was looking for here. I got a bunch of hidden files over here that I don't want. Goodness gracious, Windows. Ah! Making all this extra work for me. Let's copy this file over and see what it sounds like. Can we hear it? If I'm really quiet, can we hear it? Well, that didn't work. Well, now I've opened up the wrong program. That's not what I meant to do. This is what I meant to do. All right, do we hear it? It's not sounding. Nothing is making a sound. It is big, but not working. Okay, if I just start it here. I think it crashed before it saved the file. Okay, guys. Let's try it again really quickly. So open up a console. So that was a failed experiment. Let's go to my speech file. I don't think anything is in here. Okay, nothing is in there. We're going to try to make it again. So let's do SVAR 1600. We're trying to make some recordings. We are trying to make some recordings. I don't know why I'm counting 3 seconds. I literally have a stopwatch right here that'll tell me 3 seconds. Ah! Well, that's not working. Can I make a recording? It's super simple. Come on, Oscope Wizard. You can do this. Open up a new simple SSH FTP. We have multiple files in the directory. This is a good sign. I think we have made some recordings. We just made a new recording. It appears to be filling up that one file that is right here. You know what it is? I think that I'm not waiting the 3 seconds. 3 seconds, guys, when you are in front of people, 3 seconds of utter silence is an eternity. But it's working. It's working. Okay, so let's listen to one of these and see what it sounds like. So, oh, did you guys hear that? Did y'all? Can you hear it in the chat? I'm not sure. Let me unplug my lapel mic here. You're trying to make some recording. Ah! All right, so we made a recording. This is all working. It's all working. I don't know why I'm counting because I literally have a stopwatch right here that tells me. All right. Okay. You know, I'm trying. I'm making recordings. Now we have to stop it. And actually, you know what? I don't think we have to stop it. You know what we could do? Instead of crashing out, let's make a new terminal window. So we have a new window. So now we have 2 terminals connected. One terminal is busily recording us as we talk. So this terminal right here is going to busily record us. And this terminal, let's use this terminal for our deep speech. So we want to try to do some deep speech here. Let me plug back in my lapel mic, and it's going to busily be recording. You can hear sound, not clearly. Chat says not clearly, but we can hear sound, which is the most important thing. I could actually put the sound out to, if I was a pro YouTuber and not a trier, I could make all of this work. Okay, so here are the recordings that I have made. The first recording, what did I say? The first recording, I said, we are trying to make some recordings. So let's just use the file name here. And I think I think, guys, that we can work on a decoder. So I copied the file name. Now I have a command. We're using deep speech. So here's the command. So it's using this model deep speech. Eventually, we want it to use, what do we want it to use? We want to use incron, which is going to monitor a directory. But in the meantime, let's try this. So if I put this inside of quotes, will it work? Let's see if it will. Okay. So I'm going to tell Deep Speech to look at this file that I just recorded. We're trying to make a recording. And then it should spit out a subtitle or a file in the text directory called Subtitle with the date. So let's see if this command works. I'm pretty excited. We will copy this command. Oh my gosh, guys. 5 minutes remaining. Let's set up 5 minutes remaining. Start it. Now I feel like I'm racing against the clock. It's a lot happening. Here. Main scene, we're back. We are going to check out the text directory to make sure nothing's in there. Nothing is in this directory. Let's issue our command. So Deep Speech, use the model that is in this directory, which I downloaded. I think it's the latest model, 8.2. And then a scorer, which should help determine whether or not the words are correct. And use this audio file that we just recorded, and then output the results into a file in the text directory. Let's see what happens. I'm going to hit go. And things are happening. We're loading the scorer. We're running inference. It took 12 seconds for a 3.328 second file, which is not impressive. That is super not impressive. But that was the first time we ran it, and I've noticed that it actually gets faster over time. So if I go back over to the text directory, guys, we have text. What does it say? We are trying to make some recordings. We're trying to make some recordings. Okay. This is going to be awesome. Can I get that out to my lights? I think I can. And then once I have all that working, it's just simply automating this whole process. Yeah, I think I can. So I have a file here, a program called the oscope _ test message.python. So this guy reads a file. So I'm going to send it a file name, and then it reads it into text. It closes the file, and then it tries to get that text out to the display. So let's try this. So let's close this. I don't need to make any changes. We are going to do sudo, because to use the NeoPixels, you have to be a super user for some reason, unknown to everyone. Sudo Python 3, we do everything in Python 3. We're Python 3 show. Strong work. My chat. Oh, this is my sister helping me out. Thanks, sis. I appreciate it. We needed the help over here. We're really struggling. Okay, so run oscope wizard _ test message.py. Let's do the directory, which is home, py, text, x, subtitle, this. This is the subtitle we just made. I'm going to hit enter, and we're going to see if it works. No! Oh, no! It crashed. Oh, we got a strobe light again, which is unfortunate. Strobe lights. We got 1 minute. We got 1 minute. Can we actually get it out? I might have to. I wonder if I have to disable. This would be kind of crazy. Do you have to disable the microphone while I am outputting the lights? Is the microphone using... I wonder if the microphone is using D... That might be what it is. You know what? Well, what am I doing? I'm on the wrong screen here. I'm looking at one screen and trying to operate on another one. Okay, we're reconnected. Real quickly, let's open up a terminal, try to issue that command again, close all windows, new terminal. We're back in. Can we issue the command? Okay, so sudo python 3 oscope underscore test message /home /pi /text /subtitle. Can it? Will it do it? Okay, look, it did it. We are trying to make some recordings. I might need to adjust my I might need to adjust my text size, but look, it's working. We got subtitles out. It wasn't great. I think if if we were trying to walk around with it, hold on guys, I have a recording, I need to do some steps, but you will hear the subtitles in 12 to 15 minutes. Woo! Woo! We did it. We managed to get a recording in. We got the recording decoded into text. We got the decoded text out to the LEDs. And I think that our microphone and our LEDs are sharing the D18 pin, which is most likely causing the crash when I try to write to the LEDs while I am actually recording. So I probably just need to choose a different pin to write to the LEDs. That would be the easiest solution, and that should be pretty easy. So you know what? Next time on the Oscope Wizard, we have something to look forward to. There's always something to look forward to. We will attempt to get this process automated using incron, and then we will, I guess before we automate the process, we will figure out how to write to the LEDs while I am still recording sound, because those two things need to happen simultaneously, one happening on top of the other, or in parallel. Simultaneously and in parallel. I think that means the same thing in the English language. English nerds out there? One day you might, and the chat's like, you need to let us hear the truck engine. I wonder what the truck engine subtitles would be. It'd be like, blah, 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 blah. Yeah. I don't know all the nerds in the world, but I would love to meet them. So please share this with a nerd in your life. I'm going to hang out in the chat, nerd out. Looks like with my sister, which will be great. I haven't talked to her in a little while. And I will see you guys on Baby Friday. Bye.